Hey, welcome to 42 Podcasts. I go by the name of Desh, and today I'm speaking to a young scientist from University of Sydney, Petr Lebedev. We tackle everything from NASA, the Russian space program, the Australian space program. Is nuclear a good idea? Science denialism, among many other things. I had great fun talking to Peter. So here it is. Hey, Peter. Welcome to This is 42 Podcast.
Thank you so much for having me.
Great. So, Peter, who are you?
That's a really good and deep and existential question. Who is anyone? So I am a human being. I'm mainly made out of carbon, and there's a lot of water, like 70-80%, something like that. I'm currently a PhD student at the University of Sydney in the School of Physics, and I'm doing a PhD in physics education research. So basically, I'm part of a group that's trying to figure out how to teach physics better.
Right.
And I'm a science communicator in my spare time.
Right. Great. So I've got a lot of questions.
Good.
So I'm going to start off with an easy one.
Okay.
Your name suggests Petr Maximovich Lebedev.
Yeah.
That there is a Russian connection.
Yes, there is a Russian connection.
Your T-shirt tells me NASA. So where does your
where do my allegiances lie?
Because you be a traitor.
My allegiance lies with humanity,
right,
and science and exploration and all these cool things.
So I know I jokingly said that, but Russia used to have, and I think to a certain degree still has, a very interesting, space program.
Yeah.
Now, the last thing I read was
the Soyuz crash.
Yeah, there was a bit of a crash happening. But the point is, NASA is sort of universal. When I was in Sri Lanka 20 years ago, I knew about NASA, but I don't even know what the name of the space agency for Russia.
Yeah. So Russia's space agency is still ridiculously good.
Right.
Up until a couple of days ago, which we should talk about anyway.
Yes.
So the Soyuz, right, is the only way that people can get to the International Space Station right now.
Really?
Right, and it has been that way since the shuttle retired.
Wow.
Right, so for the last, 10-something years?
So I remember, this is a good place to start. So I read about the accident that happened, but I think you can explain it better than, what I read was, I feel like something superficial, like, something went wrong and they had to crash, they have to basically abandon the whole flight. So what really happened?
So from how I understand it and from what I've read, basically there was a problem with one of the engines in the Soyuz, right, which is the capsule that takes people to the ISS, and it was actually really strange. There was a 2-person crew, right? It's usually a 3-person crew that goes up, and they had to abort at a certain time, and basically there's a kind of an escape mechanism where there's just these smaller engines that are just kind of explosively rip where the people are to keep them safe.
So, which brings to the point. So, the only way of all of humanity to connect to the International Space Station is this one organization that.
Right now, yes.
Right, and is there? I would be surprised. Like, isn't anyone else?
Boeing and SpaceX.
Boeing and okay.
Right, so SpaceX and Boeing are both contracted to I think it's like next year and 2020 respectively. I think SpaceX is first. Right. So that's actually something SpaceX have been working on for the last couple of years. Okay.
Right. And how do you think that is going to affect the Russian space program moving forward?
Yeah, I don't know. Like that's really interesting. I'm not an expert, sadly, in the Russian space program. But yeah, like that's a big part of the Roscosmos. That's the name of the Russian space program.
What is it again?
Roscosmos. So
what does that mean?
Russia space, like cosmos is space in Russian, right?
We were speaking earlier. Another little fun thing I learned today is Russia is very good at naming things. It's literal.
Yeah. So all of the kind of the landers and orbiters that Russia sent, if it's the moon, it's Luna. like 1, 2, 3.
1, 2, 3, right.
Right. So yeah, the moon 1, 2, 3, or Venera, right? Like up until like 18 or something, right? So like Venus 14, right? So
okay, so from Russia to America and to Australia, really, because I mean, we were all, I think for a certain degree, I'm not a scientist, but I had an affinity towards NASA. NASA is this amazing sort of enterprise. But in Australia, it was an announcement not so long ago that we're going to have our own space agency.
Yeah, about a year ago.
Yeah, and right now we don't have a cool, any marketing or nothing like that. How do you think we should approach it now that we know like how NASA worked and how Russia rather didn't necessarily work because people don't know what it is?
Sure.
How do you propose we get this whole idea out there?
Well, they launched a Twitter a couple of weeks ago, so that's a good start.
So there's an official Twitter?
There's an official Twitter. I think it's like a Australian Space Agency or something. It doesn't currently have a particularly catchy name.
Right, Australia.
Which I really think we need a catchy name.
I want to go sign up to this one.
Yeah, good.
Australian Space Agency.
Into Twitter, you should be able to.
So, ASA. Okay, it doesn't really.
Yeah, no.
It's like a ripoff of NASA.
Yeah,
it's a cheap Australian knockoff.
It needs a good name and it needs a good logo.
Yeah. All right. Cool. Now, with what you are, yes, I found it. I'm going to follow this.
Yeah, good.
Hey, look, the good news is there's already 4,500 people following it. And by the time this podcast comes out, there'll be more. It's great. Okay. Now, Australia has a rich history with regards to space exploration.
Yeah.
There's people here that have been part of some of the most important missions in history, but it's not really public knowledge. And you have some stories, and some of the people that you interact with have been part of very important, whether it's NASA or the Russian space program related. You mentioned somebody who was part of the...
Harry Messel.
Yes.
So Professor Harry Messel set up the school, was one of the key players in setting up the School of Physics.
In University of Sydney.
Yeah.
And his involvement was?
So during Sputnik 2, which was like the second Russian, like in 1959.
Yeah.
1957? I think it's 57. Where there was actually a dog on board called Laika. The Harry Messel was one of the people that intercepted these signals that the spacecraft was putting out, like these radio signals, and they were encrypted. Right, because again, like this is the start of the Cold War, right? Like it's the start of the space race. Yeah. And what's really interesting is if there's a community of space scientists who are like, guys, can we please, like, we want this data. This is really fascinating. Like there's if the codes weren't encrypted or they were given the access code, there's a good chance they would have found the Van Allen radiation belts, right? Like a year before the Americans did. But anyway, so that kind of ties into the importance of like open access science, right?
Yeah, that's another thing we got to talk about. So there's a few exciting sort of young scientists out there, and like you're on the come up, and then people like Alan Duffy. I think you guys need to figure out. You met with one of the most notable names globally when it comes to science communication, Bill Nye.
Yes.
I think we need a few of you who's sort of influencing sort of the mainstream Australia if the Australian Space Agency were to have sort of like the cult-like following of NASA.
Yeah, so I think what's really interesting is that Bill, Alan, and I all look very good in bow ties, right? Like that's actually, I had an interesting moment where so it was lucky enough to hang out with Dr. Carl and Bill Nye at the same time, and I have a bow tie, and I brought along a spare bow tie for Carl,
right,
just in case he didn't have one, and. So I had to tie a bow tie onto Dr. Carl as Bill was looking over my shoulder. And just like it just felt like the most intense exam.
Yeah, there was some pressure because he'd be like, you're doing it wrong.
No. He complimented my bow tie. He thought I was okay.
Oh, that's good.
Yeah.
That's
it's very good.
Talking about Bill Nye,
Sure.
I was listening to part of your conversation with Bill Nye, and Bill had an interesting question, and you had an interesting response. I'm going to ask you the same question that Bill asked you, which was, what is it that we might believe in that with regards to science that we probably will look back and think, well, were we right or were we wrong?
Yeah, that's.
I think I butchered the question. I think what he said. You remember the question. I'm going to try to find the audio and insert it here.
Sure.
So what is it that you think we might believe in now that's wrong? I think about that continually. That's a good question for any student, actually.
Because what you and I believe, Bill, each individually is correct, and anybody else is wrong.
Absolutely.
Yeah.
And I have to deal with them every day.
Now, the important thing is your initial answer was everything.
That was Tom's. That was not my answer.
That wasn't you.
That wasn't me.
Oh.
I actually disagree with Tom on that one.
Right.
And then, from what I remember, Tom Gordon, who's a science communicator at the University of Sydney, his answer was something like, most things. I think our understanding of most things will change.
Yeah.
And I kind of see what he's getting at, but I think fundamentally there's a lot of things that are really well established that really there's no reason to change them, if that makes sense. Like, just because Newton's laws don't work that well for most things at very, very fast speeds and very, very big masses or very, very small particles, doesn't mean they are wrong.
Right.
They're still within, like 7 standard deviations of what is normal, right? Like they work really well for calculating when you throw a ball, right? Or when a car crashes into another car.
That's right.
You don't need like Einstein's theories for this until you get to the size of stars and black holes.
I think
the massive stars and black holes.
Listen to that podcast that I'm referring to.
Yeah.
Somebody mentioned Isaac Asimov.
That was me.
That was you, right?
That was me.
I took the time and actually read that essay.
Yeah.
And that is amazing,
his
amazing explanation. So I'm going to give you the privilege to sort of explain
Sure.
it. There's this awesome story of somebody reaching out to Isaac Asimov and him responding. This is pretty much the crux of the essay. So he said something along the lines of, what is wrong in the eyes of XYZ.
Yeah.
Do you wanna
So
tell the story?
I think that what's the essay is called The Relativity of Wrong or something.
Something along those lines.
Something along those lines. And the crux of it for me is like in kind of the statement when he says, if you think the Earth is flat, you are wrong. If you think the Earth is a globe, if it's a sphere, you're also wrong.
Yeah.
Right? But like if you think that both of them are wrong in the same way, you're more wrong than either of them.
Yeah.
Right? Like so just very well-written, very fancy way of saying that there's different ways of being wrong.
And that notion of, we are in a interesting place, globally, where this binary view of the world is quite prevalent. There's a very black and white approach. You're right or you're wrong. Things like that. We're going to get political in a minute, but
sure,
the point is, it's interesting to see somebody, quite a while back explaining this, and science doesn't necessarily try to prove itself right, because
you can't do that.
It doesn't make sense, and
you just can't. You just can't do that.
Yeah, you just mentioned earlier, certain very valid working scientific theories we use to measure things at a certain level doesn't necessarily work, but that doesn't mean it's wrong, right? Now, which brings me to the PhD you're doing. You want to be more or less ultimately sort of understanding the science communicator's realm. And you are a science communicator. You are on your way to becoming a science communicator. How do you communicate something that on the face of it looks simple, but it is not? Do you have a plan of attack?
Yeah, so that's a great question. That's a really, really good question. And I think for me, I like the ideas of like researchers in education where it's called constructivism, right? And it's the idea that instead of your role as an educator, and I'm not conflating science communication and science education, they're different things, but for this scenario, I think they both lead to the same thing, which is instead of the educator being this person that stands in front of a blackboard and gives a lecture, right? That's just kind of like, here is me disseminating knowledge to you. That's not really effective. Like it's effective in a lot of cases, but in a lot of cases it's also not effective. And the thing that I like is just going, hey, what is your understanding of, again, like Newton's laws, right? Like, what is your understanding of, for every action, there's an equal and opposite reaction. Like, what does that mean to you? What does that look like to you, right? Like, don't write necessarily the equations, but like you have two cars crashing towards each other, write the force vectors, like those kind of things. And then, like, if you get it right, great, fantastic. I don't need to teach you anything, right? But if you get it wrong in a kind of a certain way, I now have a better understanding of where to, So I think it's kind of to make a metaphor. It's kind of like just walk over the bridge to the other side to understand where kind of the general public or your students or whoever are coming from, right? Know that they're not stupid for not understanding something.
Right.
And I think that's actually a really hard thing for science communicators to understand. It's like, I've been doing physics all of my life.
Right.
I've been both my parents are physicists. I kind of had to, right? So it's been a very, like, I don't remember what it is like to not think like a physicist. So there's a lot of things that seem ridiculously simple to me, and I just need to remind myself, like, that's actually not the case for the average person. And that's not a bad thing. Yeah. It just means that I need to work on that level.
So, which brings me to an interesting question. Can there be an argument for where it's a bad time to be a science communicator? Again, this comes from an earlier conversation we've had, where there's a few amazing science communicators, and the general consensus is more science is better, right? And people like Neil deGrasse Tyson's and Michio Kaku's, explain things just stunningly beautiful, and you just listen to it, you're in awe. But is there an argument for science communication to sort of pause at a point?
Yeah, I don't know.
You don't know.
Right? Like, so the simple answer is I don't know, and that is something I've been thinking a lot about. Right? Like, I want to make a career out of science communication, right? Like, but I also want to make the world a better place. Right? It's kind of like, and is science communication always making the world a better place? I don't know. Right? Maybe not always. I think in most cases, right? I think more science communicators, more science in general, more educated public, right? Like, all of those things are good. But there is interesting research, again, in education, which actually Derek Muller did as part of his PhD, who now is, Veritasium, right? And basically his research was, here are these 4 videos that teach, again, something about Newton's laws, right? And we're going to give you guys a test before, right? Then you're going to watch the video with the explanation, right? And then we're going to give you a test afterwards. And like, we just changed the video. There were 4 different types. And there were different levels of effectiveness, right? Like for one, there was basically no learning gain. And for another, there was actually a substantial amount of learning gain. But what was interesting, and this is like statistically significant, for all 4 videos, the amount of confidence went up by basically the same amount.
Right.
So the group that learned basically nothing, their confidence increased just as much as the group that learned quite a bit. Right. And that, I've been thinking about that result for maybe like a year now.
Right.
And it's kind of like, isn't that kind of what science communicators do? We try to explain things as clearly and as concisely as possible. Derek's research seems to show that that's not always particularly effective, but the confidence goes up.
So
it's like
is the sample size? Was the sample from
significant?
So it's significant sample, and is the sample size from sort of academia?
Yeah,
or?
it was first-year physics students.
Right. I think that maybe this is a hypothesis, but I would say if you're a university student, if you're studying a certain stream, there is a certain set of expectations you have.
Yeah.
Science communicators speaking to a mainstream audience would have a different impact.
Sure.
For, I think, if you're going down the academic route, maybe I can see how that would work. But if it's the mainstream audience,
100%.
I think it would be a different impact, because the sheer number of people that I have spoken to, because I've had the privilege of hanging out with few people like Neil deGrasse Tyson and Richard Dawkins and whatnot, people knowing certain science factoids purely because they watched a bunch of YouTube clips. A few people knowing, biological facts.
Totally.
So
don't get me wrong. Don't get me wrong. I think a lot of like I learned a lot about all types of sciences right from watching YouTube.
Yeah, right.
And from reading books. It's kind of like there's no doubt that a lot of informal learning still happens. I'm not denying that that's a good thing. What I am trying to say though is maybe it's really important to remind people that just because you watch the YouTube video doesn't mean that you're necessarily an expert, right? Like, and that's an important, potentially for me is just kind of like, hey, at the end of the day, please think for yourself.
Yeah.
Right? Like, I am just another, guy in an ivory tower that is hoping to get his doctorate someday and blah, blah, blah. Like, don't trust me because hopefully I'll have doctor in front of my name, right? And don't trust Neil deGrasse Tyson because he's Neil deGrasse Tyson, right? Like, people are still people. People still get things wrong. I'm not saying don't take their knowledge for someone else's ignorance, right? But I am saying read the original paper if you want to, right? Like if you want to become an expert in physics, go do a physics degree.
So,
right, like
I agree with you. Now, all this talk about science communication was actually leading to a video I want to show. This is so the original video is about an hour and a half, but this is like a 4-minute excerpt. Now I will link to the original video, but this is a bit old, so this happened some time ago. I don't know if you've ever seen it. So this happened in 2016 at UCT science faculty in, I believe, South Africa. I'm going to play this video and then...
Is this the decolonizing science one?
Yes.
Is this the magic is lightning?
Yes. Okay, so you have seen it, but for anybody who hasn't have not heard it, we'll play a little bit of it now.
So can I respond to your submissions, because I wanted to directly respond. I was actually thinking about this coming here because I thought that it was going to be one of the coming questions. How do we even start to decolonize science? Because science is true because it is science, and what can you do? And my response to that was, if I personally were committed to enforcing decolonization, science as a whole is a product of Western modernity, and the whole thing should be scratched off, especially in Africa. So if you want practical solutions to how to decolonize science, we'd have to restart science from, I don't know, an African perspective, from our perspective of how we've experienced science. For instance, I had a question for all the science people. There's a place in KZN, in Ukabialingana, and they believe that through the magic, the black magic, you call it black magic, they call it witchcraft, others, that you are able to send a lightning to strike someone. So can you explain that scientifically? Because it is something that happens So I will finish. See, that very response is the reason why I am not in the science faculty. I did science throughout my high school years, and there was a lot of things that I just, but it's fine. But Western modernity is the direct antagonistic factor to decolonization, because Western knowledge is totalizing. It is saying that it was Newton and only Newton who knew or saw an apple falling, and then out of nowhere decided that gravity existed and created an equation, and that is it. For whether people knew Newton or not, or whether whatever happens in Western African thing is the only way to explain gravity is through Newton, who sat under a tree and saw an apple fall. So Western modernity is the problem that decolonization directly deals with, to say that we are going to decolonize by having knowledge that is produced by us, that speaks to us, and that is able to accommodate knowledge from our perspective. So if you're saying that you disagree with her approach, it means that you are vested in the Western and Eurocentric way of understanding, which means you yourself still need to go back internally, decolonize your mind, come back and say, how can I relook at what I've been studying all these years? Because Western knowledge is very pathetic, to say the least. I, from a decolonized perspective, believe we can do more as knowledge producers, as people who are given the ability to reason, or whatever is that people say we do when we think or rationalize. So decolonizing the science would mean doing away with it entirely and starting all over again to deal with how we respond to the environment and how we understand it. Thank you.
So Peter, you just saw the video, and we sort of rewatched it again. And for the listeners, obviously, this particular piece that I played is not edited. So, but if you want to hear the full context, you can watch the hour-and-a-half version of it. But really, my question is, how do you explain to somebody who, as a science communicator, so the girl who's making these claims, she obviously have genuine grievances that potentially that relating to Black African people, and South Africa at one point was a very racist country, but in the context of what she's talking about, she's in my understanding of science, it feels it's quite obvious that the way she sees or uses the word science is very different to what science is. So as a science communicator, how do you, let's say you're in this position, right? You have to address a group of people who say things like science has to restart. We have to science from an African perspective. How do you address somebody who potentially have some grievances, but how do you address somebody like that without offending them?
Well, okay, I think we should separate what we think science is and what it should be.
Right.
And what science should be is this objective, self-correcting, rigorous way to study, the nature of reality, right? And it needs to map on to it needs to give us a good predictive map of the universe, right? So that is what it should be. And I think in a lot of cases it is. But it is also a messy and ugly human endeavor that is, just influenced by humans and influenced by human history. And human history is not good to minority groups, right? I think it's incredibly important that we increase the amount of women who are studying physics, right? For other sciences, it's maybe a little bit more even, but with physics, it's 80-20. It's right. 80% men, 20% women. And that sucks. Right, and that sucks for a lot of reasons, and one of the most kind of even if you're a person that just doesn't care about individual people and women's rights and blah blah blah, it sucks for a reason of there's just simply less brains working on physics problems. The more brains that we have working on physics problems, the better, right? In my opinion, right? So I started with going look, there is a there are historical problems with science and potentially the way that we're teaching it and all these kind of things. What I would say about the rest of that, though, is just because there are historical problems, right, doesn't mean that all of science is faulty and wrong and that we should restart it and give it a different perspective. It's kind of well, maybe in your classrooms, right, you can there's cases of simultaneous discovery everywhere and not simultaneous discovery, Snell's law, right? It's the law that basically governs the angle at which light, and actually sound, funnily enough, changes, like the angle that the light goes at when it enters a different medium. So for glass or for water, it's called Snell's law, after this Dutch guy, Wilburo Snellius or something like that. He had a lovely mustache.
Right.
But it was the first written case of it was 981 by an Arab scholar, right? Ibn Sal, right? Like, and he there's like a lot of science is, like, a lot of scientific discoveries are named after men, and they're usually named after white men, right? For just the terrible quirk of history. So like I can understand the genuine grievance, right? And like, sure, maybe in your science classrooms talk about in the Australian case, it's like, talk about the discoveries of the indigenous astronomers. Right, like they're there, and there is actually a record of it, and we can see it, and there's actually really amazing papers about it, right? So please include that in the curriculum.
But how do you then tackle when she makes a claim about sort of somebody magically wishing a lightning bolt on somebody else?
At that point, you go, you're not doing science,
right?
Right, like, but like, I'm not sure if I would say that directly, right? Like, I would just be like, that's not, like, if a person is genuinely summoning a lightning bolt, like, please give me the evidence. I would like to study this. That would be super cool.
That would be, right? Like we have a super.
I'm not saying that this is like something that. Like, there's no chance of this existing, right? Like, it's probably not breaking any, like, the way that she's phrasing it, it's probably not breaking any laws of physics. It's just incredibly weird and unlikely, and the case is, like, it's probably not black magic, it's probably the Tesla coil that they strapped on their back, you know, like...
Yes, there would be... So what you're saying is that there would be a scientific explanation that we can sort of comprehend.
I mean, there's probably not a thing that is happening.
No, I don't think so.
But if it was, I'm sure there is still a scientific explanation for it, you know?
All right, so still on the realm of energy, but I'm going to bring it back to Australia.
That was tough.
Deliberately, because look, the context is, when I first saw this, my jaw dropped. I couldn't believe what I was hearing and how this is an actual thing that's happening. And this came out the time where sort of there's a large movement in America where free speech was being challenged at places that it was unimaginable. At a university where, generally you can debate, challenging subject matter, philosophical or scientific. You can do that. I mean, university is more or less custom built for that. But there's this was 2016 where it's sort of the beginning of this, big movements to shut free speech happen. So for me, it's important, like you as a science communicator, as you move into a realm where there's a relatively large group of young people who may have, for the right reasons, they may think their intention is good, but they think along these lines. Then you are faced with the challenge. How do you talk to these young people? And then that was the purpose of my question.
Sure, for sure.
With that said, let's bring it back to Australia. Still about energy, completely changing the subject matter.
Sure.
I wanted to ask you about Australia. Whether we like to admit it or not, we've had an energy crisis for a little while. In the sense of there's places in Australia where we had blackouts, and Elon Musk has to come and build the largest battery, Australia also has a government that historically the current government have been more leaning towards traditional methods of creating energy, less towards sort of renewable energy. And there's also an energy source that is almost like a taboo. People don't want to talk about it, which is nuclear.
Oh, wow.
Right?
Okay, we're going there.
All right. I want to know from you being a physicist, you have a decent understanding of what I've seen you talking to people who try to understand fusion and fission energy.
Sure.
So the question is this: is there a realistically safe ways for us Australians to explore an avenue of nuclear energy?
Okay, so I wanna, but before we go there, I wanna talk about difference between fusion and fission.
Yes.
So fusion is what the sun does.
Yeah.
Right. You basically take usually light atoms, light molecules, and put them together, and you create something heavier, and that happens to release a bunch of energy, right? So that's what the sun does with like hydrogen, and it creates helium, right? Or so this is something that happens. Like, this is something that humans can do. It's just you need more energy. You need to put more energy into the system than you're currently getting out of it. There are physicists who are studying this, a bunch of my friends, right? Like they did their honors projects doing exactly that, trying to increase the rates of fusion, right? So that's really cool, because the negative externality from it is water, right? Oh no, right? Water is the waste product from this. Then there's fission, which is what we usually think of when you talk about nuclear energy. And it's taking like uranium, plutonium, whatever, and it's falling apart into lighter elements, and also releasing a bunch of energy. And we use basically like that heat to heat up a cauldron, basically, and then spin turbines.
Right.
What do I think about nuclear energy for Australia? I don't know. I'm not I'm not an energy specialist.
Right.
I'm not also a risk kind of management specialist. Right. As a science communicator, my opinion is I don't know. As a person, I think I'm leaning more towards like the best case is solar and wind. Let's get on that as quick as possible. Currently, that is not happening. And I worry more about climate change, the huge detrimental effects of climate change from the basically burning coal, which is what we're doing. This is how we're powering our lights in Australia. I worry about the negative effects of climate change more than I worry about the potential risks of nuclear.
Right.
So we're not... Australia is not the Soviet Union. Australia is not we're stable both politically and with kind of health and safety, and we're also stable from earthquakes.
Yeah, earthquakes. Right.
Right. So the kind of the two big, 3 Mile Island as well, but like the two biggest kind of catastrophes with that were Chernobyl and Fukushima. Mm-hmm. Right. Chernobyl can be just due to overworked crew and not enough health and safety regulations, right? And Fukushima is because of a ridiculously powerful earthquake and a very, very strong tsunami, right? So assuming that we kind of manage all of these contingencies, the risks are managed, I could vote for like a party that promotes nuclear energy. But that's something that I think we should be like discussing, right? Like I don't tend to talk about it that much because it's very unpopular.
Yes. The idea of nuclear is directly associated with Fukushima and Chernobyl because it is a disaster waiting to happen, is the general narrative. Which brings in, the next thing I want to talk to you about, which is, who are your favorite YouTubers who's doing science?
Yeah, cool. This is Derek Muller, so Veritasium.
Yes.
He's kind of the reason I'm in Sydney.
Yeah, right.
Destin from Smarter Every Day. He's absolutely incredible. Henry from Metaphysics. If you haven't seen 3 Blue, 1 Brown, he's an incredible person at explaining maths really clearly.
I'm going to make a note because I'm never good at maths.
Please do. Vanessa Hill.
What is it? 3 Blue?
3 Blue, 1 Brown.
1 Brown.
Like blue, brown. Yeah, so Vanessa Hill from Braincraft, I think she does great work. The Michael from Vsauce and Jake from Vsauce.
Yeah.
They're just so very good. Yeah, there's a one of my friends called Toby. Her channel is Tibes, Tibwees. She's very cool. Right? She does a lot of really cool stuff. There's just honestly, just a plethora, right? Like a cornucopia of amazing.
That's pretty amazing. That because I think a lot of people have, like for me, really, my interest into certain scientific subject matter, I can generally find a reasonably well-researched YouTuber explaining that.
Yeah.
But at the same token, you can also find somebody explaining why the Earth is flat as well. And some of these videos have incredible number of views. So how should an average individual pick the difference between
what is
scientific fact and like it's not that simple, right? You think it is. For a physicist, you probably see the failure.
Sure.
For a layman, you may fall into a trap of going down a rabbit hole that is somebody like Deepak Chopra.
Yeah, that's a great question. So, maybe the correct answer, if there is a correct answer, is having a country with really good education systems. Right? Like, hopefully, like by the time you finish school, you are qualified enough to tell the difference between what is real and what isn't and what is. But honestly, that's really hard.
It's very hard.
I think, yeah, like that's genuinely like an incredibly difficult question, because I think you kind of need to understand a little bit about how not only science works and like how it should work, but how it does in reality. So you need to go, oh, this paper that this person has referenced was published in Nature. Nature is much better than deepakchopra.com.
Right.
Like maybe one is a very credible source and the other one isn't. I'm not saying that Nature is infallible.
Yes.
Right? Like people do make mistakes. Mistakes get published.
Yes.
But just because that's true doesn't mean that one is more correct than the other. Right. So I don't know, but
the reason I sort of I wanted to we've been talking for over an hour now.
Oh wow!
I wanted to ask you this because I've had conversations with people that I interact outside of the This Is 42 universe, where science is not something they were really interested in school per se, but now they've entered into a realm where it sounds scientific, but it is not really science. For example, I've had somebody recently telling me about they started a conversation about energy, and I was I have a general understanding of energy in a sort of scientific context, but I soon realized what she was talking about, energy in the sense of chakras and stuff. And the reason I asked this question is, for them, for somebody who believes in that stuff, you can go to YouTube, you can go to podcasts, you can find, New Age is a legitimate section in bookstores, right? So the challenge is, I think, as a science communicator, all science communicators have a responsibility to figure out a way for the masses to pick what is what, right?
Yeah.
But
so there's a chapter in Carl Sagan's book, The Demon Haunted World: Science as a Candle in the Dark, called the Baloney Detector.
Right.
And it's that in that chapter he just kind of outlines, like, here are my best tips of determining what is science from what is pseudoscience. Right.
So Carl Sagan, for people who are really interested in science, have a really we know who Carl Sagan is.
Sure.
But again, for today's mainstream audience, Carl Sagan is not a household name.
No.
I mean,
Neil is.
that's true. That's true. So, but we need more Neils, right?
Sure.
But we also need Neil's what I would call like a superstar level.
Yeah,
right?
yeah, totally.
He's the mainstream performer. But then there's more need to be out there, such as this is what you're trying to do.
Yeah.
So what Derek is doing. So again, which brings back to
there's a few steps between me and Derek and Derek and Neil, right?
Yeah, there's a fair few steps there.
No, not necessarily in quality. It's just like Derek's work is really great. It's just like the millions of dollars.
Derek is great, but the point I'm trying to make is, I feel as there is still an audience that sort of science communicators such as yourself and Derek and Neil have not been able to reach.
Yeah.
And this audience requires a scientific and a philosophical approach. I think because Australia is an amazing place to live, but Australia is largely a secular country. A very large part of this country it doesn't identify with any religion. And I feel as from this large pool, people are replacing the traditional religions with sort of this finding meaning and purpose through sort of new age avenues.
Sure.
And that group of people aren't necessarily interested in science in sort of how Derek would explain or Neil would explain. I think that's what I mean by there needs to be science communicators who are willing to sort of tackle a little bit of philosophy within the context of science, so you can attempt to answer morality questions through science, ethical questions through science. Science generally, like I know Neil doesn't necessarily go down that path that much. This is, for you, what you're doing, do you feel like it's important or
I think it's really tricky, right? Because I'm not in the business of telling people what to think.
Sure.
Right? And especially I don't want to be telling people how to live their lives.
Sure.
Right? Like I don't know how to live my life, right? Like I'm definitely no authority to. I'm maybe one of the kind of the weirder side of science people that thinks that science does give us a lot of answers to moral questions and a lot of ethical questions. That's maybe that's another hour-long conversation, I'm sure. So you're kind of asking how do we?
So my question is, my question really is, do you think I have a point here that scientists do need to dabble in philosophy to attract an audience that normally doesn't get into science? So, for example, like the person I was talking about, she wouldn't really necessarily be interested in sort of looking at how fission and fusion work, but she would be interested in working out certain philosophical questions about.
Yeah. So one of the things that I actively try to do as a science communicator isn't necessarily I want to engage people on an emotional level, right? Like science for me is an incredibly emotional thing, right? I talked a little bit about life on Enceladus, right? Like one of the moons of Saturn, right? There's, in my opinion, right, like from all the data that we have, there seems to be a really decent chance that there's some sort of life, right? There's water and there's heat, right?
And for listeners who are listening to just for the podcast, go check out Cafe Classroom. The link will be down somewhere, which explains what we are talking about here.
Yeah, sure. But so there's water and there's heat. There's a really decent chance that there's life. I know that I'm kind of pitching it as a science, cool science fact. But for me, it's so much more. And hopefully for other people, it's so much more, right? It's kind of there is maybe life on another planet that is not.
I see. So you're telling,
it's
you're telling a creation story.
It kind of, right? But
yes,
isn't
right.
evolution a creation story anyway,
yes.
right?
This is the thing. So I've been trying to wrap up this conversation, but
sorry.
This is so interesting. You don't need to apologize. It's just me, because I think one of the things religion got really well is to tell stories.
Yeah, 100%.
It's a creation story, right? Evolution, you're absolutely right. It is a creation story, but it is not told as a creation story in the sense of from a storytelling perspective. It is. I feel
good writers.
Yes.
Like there's a wonderful what was it? Adam. I forgot his name. He wrote a book called A Brief History of Almost Everyone that came out a couple of years ago, and just a new one that I just started reading.
Right.
Called The Book of Humans.
Book of Humans. Let me have a look.
And so he's a brilliant writer he's a geneticist and a brilliant writer from the UK.
Adam Rutherford.
Yes. That's the one.
Right.
Like so I think that there is actually a big push in science communication towards storytelling. And like that's something that I'm really interested in.
Right.
As a I want to figure out how to tell better stories in general. Yes. But the main goal is how do we tell better stories about science?
And Peter, I'm looking forward to reading some of your stories, hearing some of your stories. I really appreciate you coming in to This Is 42 podcast.
My pleasure.
We'll definitely have you in again down the track.
Sounds fun.
Thank you so much, mate.
Thank you.
Awesome.
Cool.
Hi guys, thank you so much for watching. If you like this video and want more, don't forget to like, subscribe and leave a comment because we'd love to hear what you think. Until next time.